Today we're going to take a look at the normal curve, normal distribution, and this is going to be our second day of it. So if you haven't watched the first day yet, you might want to go back and do that. So the first problem we're going to look at, eggs laid by a chicken are known to have a mass normally distributed with a mean of 55 grams and a standard deviation of 2.5 grams. What is the probability? So, actually I think I'm going to add this to a different page. We're going to need a little bit more room here. So let's see. All right. So from yesterday we talked about this. If this is a normal curve, normally distributed, our mean goes in the middle. And then our standard deviation is 2.5. So if we go up by 2.5, 57.5, 59.5, so that would be 60, and 62.5. And we went out 3 standard deviations on each side. So that's 1, 2, 3. If we go backwards, we'd have 52.5, 50, and 47.5. 1 standard deviation below, 2 below, and 3 below. So here's the deal. We need 59 grams. So as we can see, 59 is going to fall right in here. But we don't know those percentages because from yesterday, we knew that the percentages between the first two, that was 68%. The next two were 95%. And then the third ones were 99%. But this doesn't fall exactly, so we got to figure out how to do this because we want to know that it weighs more. So we want to know this percentage over here. So what we can do to do this is we can use our calculator. So, here are the steps for how you do that. Whoops, that's the wrong one. Let's cut that out. I didn't go back far enough. Here it is. And you guys are going to find these are really close to binomial stuff. There's slightly different names here. So, we go to calculator, stats, distribution, and normal. Now this mu, that stands for our average, our mean. And this one here stands for our standard deviation. And then it has our lower and upper bound. So this will give us our area if we just put down the lower value, the upper value, our average, and our standard deviation. So let's see here. So here is our calculator. Make this a little bit bigger. They want to weigh more than, what was it, 59 grams. So we go to menu. Whoops, let me get to that scratch pad. So menu, number 6, statistics, number 5, distribution, and we want a normal CDF. Now our lower range, we wanted more than 59, so we're going to put 59. The upper, we want it until it goes to the end, so we're just going to put a really big number in there. Our average was 55 grams, and our standard deviation was 2.5. So if we type that in there, we get 0.054799. So 0.054799. So we could just say, or this is approximate if we want to turn it into a percent, about 5.5%. So the next one, the egg is smaller than 53 grams. So we can go back to our calculator again, menu, stats, distribution, normal CDF, and we want it smaller than 53. So 53 is our upper bound, and we got to put a really small number in here, so I'm just going to go negative 9999999. Our average, again, was 55. and our standard deviation was 2.5. So we get 0.212. So 0.212, or about 21.2%. And if we look at our graph here, if we wanted to find where is 53, well, 53 is right here. So we would have below that. And then between 52 and 54, so we go Menu, Stats, Distributions, Normal CDF. So it's just between those. So that's pretty easy, our lower and upper. Our mean is 55, and our standard deviation is 2.5. So we get 22.9%. So the second one here, suppose that the distribution of hamsters is normally distributed with a mean of 63.5 and a standard deviation of 12.2 grams. If there are 100 hamsters at the pet store, how many of them weigh 78 grams or more? So if we were to draw this, we'd have 63.5 in the middle. And we could do our standard deviations again. So if we add 12.2, 1, 2, 3, 1, 2, 3. So 12.2 would be 75.7. So we add 12.2 again, so that's 87.9. Add 12.2 again, so that'd be 99, 100.1. And we could go the other way as well. If we subtract it, 63, so that would be 51.3. And we could keep going the other way, but if we notice, we want it more than 78 grams. So we're looking for right about here and above. So it's not on a nice standard deviation. So once again, we can use our calculator. So Menu, 6, Distributions, Normal. So our lower bound, we wanted more than 78. So 78 to 9999999. Our average is 63.5. And our standard deviation is 12.2. So we have 11.7. So that is 11.7%. So if there are 1,000 hamsters in a pet store, how many of them weigh more? We would just do 1,000 times 0.117. And I'll leave you to type that into your calculator to see what that is. Okay, so this last one here, the length of an instrument produced by a machine has a normal distribution with a mean of 12 and a standard deviation of 2 months. So we got 14, 16, 18, 10, 8, and 6. Find the probability that will last less than 7 months. So we want that probability right down there. So again, it's not on the nice standard deviation, so this is our calculator. Menu, Statistics, Distributions, Normal. So we want it just lower, so negative 99999. Lower than 7 months. Upper bound is 12. Oops, nope, upper bound is 7, excuse me. Our average was 12. And then our standard deviation was 2. So we have 0.006. So that would be 0.6%. Let's double check that. I feel like it should be a little bit more than that. Let's see. 7, 12, and 2. Looks like I got everything there. Oh, I guess that would be right. I was trying to, what I was doing in my mind is I was like, well, I guess if between these two is 99%, that means there's 1% on either side, so there's 0.5% less than that. So yeah, a little bit more than 0.5. Okay, and then the last one here, between 7 and 12. So between 7 and 12 is right there. So again, this is another calculator. Menu, statistics, distributions, normal. So between 7 and 12, the mean is 12, standard deviation is 2. So we have 49.4%. So you can write down 49.4 for that one. And then we should be good. And I don't know where the screen went, so we're going to be done with this one. That was the last one, so why don't you guys start your assignment?